in doing the aquarium, we're also trying to understand what the overhead of the browser doing rasterization type functionality is. And the aquarium is also very tied to the ski implementation. So you're going to see Neon instructions that, and Neon optimizations taken advantage of inside of the aquarium canvas. So ski as an example. And then the last rendering one is called a pixel blender. And for this one, we're trying to do something that's, kind of unique. We're calculating the graphics throughput for the system with the goal of trying to understand what the bandwidth available for blending and blending is. So we're putting a lot of transparent and semi-transparent images to the screen, and what we're trying to do is just blend those, change colors on them. Ultimately, again, we're trying to find the available bandwidth for bleeding and blending. And so these four, we think, are pretty good representations for the kind of content you might see on a website today. Mobile content certainly has changed. If you maintain a mobile user agent and you go to a website, you see that there seems to be a trend, a follow-on trend from a lot of websites. Right now I see a lot of CSS transitions being used. You can't actually load new pages into new windows. You kind of have to scroll through the content, which is a little bit annoying. You're starting to see more and more canvas, or at least we're starting to see more and more canvas being used. Primarily a simple 2D images, right? Something that's like an advertisement. But we do expect that some of the websites that have done casual gaming, like Angry Birds, that those are going to be kind of used more and more, and you're going to see a lot more canvas-type casual games come to the market in the near future. The JavaScript ones, I don't even know if I should really talk about SunSpider. I think everybody runs it, everybody understands it, as well as the V8 benchmark suite. The most recent iteration of version 7 is something that we're adjusting for in the latest version of Vellamo. The Surfwax binder, though, is unique, and what we're trying to do there is the interface between the virtual machine and the browser, there's a set of Java bindings, all right? And these Java bindings, you can see them through iterations of Android become more and more efficient. And so when we take a look back at, let's say, Froyo, which was the first version of Android that included V8, you get a very typically low score from Vellamo when you tried to run something which stressed these Java bindings. But over time, as they revved up the version of the virtual machine inside of the browser, as well as changed the WebKit implementation and changed the overall browser, we find that this is becoming more and more efficient. What we're trying to do is we're trying to put together a series of nested loops, right? And all we're trying to do is stress that interface between the virtual machine and the browser. And so we think this is actually one of the areas which we see a lot of stability issues if it's poorly written, or if the implementation or the integration between the virtual machine and the browser is not well done. We find that typically that exposes itself in a variety of different things, like pages not loading, right, or bugs that are showing up during JavaScript. A form element will be submittable, something of that nature. And so again, tying it back to a roller use case. The user experience test, as I mentioned earlier, flinging, like image flinging, pinching, zooming, text flinging, these are things that we're constantly doing throughout the day, and the relayout that happens as part of that with your web page, right, where a user will click and pinch zoom, right, and then you'll kind of fall back to the original site, and the page will have to completely do a relayout of that. And this is something that happens, and I think we all do quite often. And so getting those types of user experience tests into Vellamo made a lot of sense. And we typically see two, I think, broad cases. One is text, the other one is images. As an aside, images account for about 60% of the page download bandwidth that we bring down as part of an average page. JavaScript accounts for about 40% of the CPU overhead used for executing a page. So it's really kind of disparate things. Running JavaScript is CPU intensive, but it doesn't really affect the page download performance, whereas images affect the page download performance quite considerably, and that's why you see so many proxy solutions in certain parts of the world. So with Ocean Flinger, what we're doing again is we're flinging a typically complex web page. We've created a sample web page. We're flinging it back and forth. With Image Flinger, it's similar, except we're testing the image decode path, right? So as we fling the page, images are coming into the viewport, have to be decoded, have to be put to cache. and as well as text, right? So rendering of text, making sure it's smooth. And you can actually see if you have two devices, one that has an optimized version of a browser and a non-optimized version of the browser. As you're running this test, you can actually see the speed at which it scrolls, right? You can see the speed at which the images of the text move up and down the screen. Okay, then lastly is networking. So with the networking test, it's a very trivially easy test. And for this first iteration of Vellamo, we felt as though we needed to get something networking in there. So it creates a local host, and it does just a HTTP download over a local host. There's not a lot of caching that's going on. There's not a lot of trickery that's happening. You can have networking guys come up here and they'll give you 1,000,001 reasons why a page might download kind of slowly, or you might go to a page 1 second and a second later it goes like twice as fast or twice as slow. There's a lot of contention from just your network. There's a lot going on the device. Ultimately, what we find with networking, though, is that it's very regionally influenced, right? So in San Francisco or in hotspots like New York, you might get a very fast page download. And when you're kind of out in the nether regions, away from a cell tower, loading over 3G, it might go very slow. Also, we find regions of the world where it's completely unstable. Really, really crazy responses from server content. Asia is one of those areas where it's really difficult to do live network testing because you're not really sure what's happening. And so having a contained network test inside of Vellamo makes sense. And in our future versions, we're actually going to expand on this quite a bit more in order to test things like networking cache, right? So how many images or how much of the content that you downloaded previously actually resides in cache over long periods of time. Again, there's a lot of defaults inside of the Android browser that establish, okay, I'm going to maintain, the last 5 websites, the images from the last 5 websites as an example, in my cache. And if you have a big enough systems as we have today, right, where we have multi-gigabyte systems and large SD cards, it makes sense to scale it up. It makes sense to do things like increase the cache size. So are there any questions about these tests? Have you guys ever taken a look at? How many people have actually looked at what the output of Vellamo is, besides just the number? Oh, that's good. That's good. That's good. And do you have any questions about those? I mean, a lot of those are opaque type statistics. At the end of the day, there's the score test, which actually gets rolled into the final test, or the final result, I should say. So, just a real brief comment on the future. Our plan is to iterate Vellamo by the end of this year. And inside of Vellamo, we're going to be adding some tests which are more CPU specific and GPU specific, right? So it's going to extend beyond just being a browser test, right? So in the first iteration, what you had was a test that was focused on mobile browsing. This next version is going to focus on things like integer and floating point efficiency, okay? As well as RAM and flash memory. So the speed at which RAM memory, speed at which flash memory, the memory bandwidth of those things. We're also going to be adding some tests to touch on some newer HTML5 concepts like WebGL. We're going to iterate through the canvas quite a bit more. Web audio and some of the W3C APIs that are coming out, we're evaluating those and considering how to actually get these into the benchmark. A lot of this is crystal ball gazing, right? So you're kind of looking at what's popular today, what's being pushed, promoted, talked about, blogged about tomorrow, and what you think is going to be available 9 months or 12 months from today, and commercially available both in content and also hardware accelerated through a web browser. And so we're trying to make good approximations. If you have some recommendations, if you're, I'm in San Diego, I don't get the regional flavor that folks in Japan or China or Europe have. So if you have some recommendations for specific content, we're always open to hearing it. And so that's the presentation. I think I'd offer up some time for questions now if you have any. Okay.
How can I ensure to my readers that Vellamo running on a Snapdragon processor we won't have different results than Vellamo running on a Tegra processor, for instance? Is there any neutrality involved?
Right, so this actually brings up an interesting point, is I think some of the, for what it's worth, comments, I think those are generated from the fact that Qualcomm does quite well with Vellamo. But if you remember, when we first launched it, the first and the highest scoring device was actually the Galaxy Tab, which is a non-Qualcomm based device, right? And I think to some extent that added credibility to the benchmark. When people saw that it wasn't focused exclusively on Qualcomm winning all the time, suddenly became something like, oh, hey, this seems to be a legitimate benchmark. I think the expectation is that you will see variance, and hopefully you will see variance in our favor, right? That the amount of effort that an NVIDIA or a TI or another SoC vendor puts into optimizing software for their particular platform is going to show in Vellamo. And so when you do the comparison of a non-Qualcomm based SoC versus a Qualcomm based SoC, what we hope you see is that all of the value that Qualcomm has added to the browser, right? All of the optimization, tying it to hardware, optimizing the software, building for our unique system SoC, you're going to see that.
So my concern about Vellamo and the reason at least we do for what it's worth is we've tested a lot of phones with Vellamo. I'm looking at a spreadsheet here with 60 phones benchmark results, and we see an intense manufacturer clustering in the benchmark results, where you can determine to some extent you can determine you can almost predict what something's Vellamo score will be by the OEM rather than by any other aspect, including the browser, Android version, processor, and screen size. Yeah. And now, if that was consistent across all web-based benchmarks, I consider it a real thing. But BrowserMark disagrees with you quite violently on that one. And so, given that BrowserMark is a much used much broader and done by an independent organization, and also because the BrowserMark results seem to be more in line with the hardware of the device, as opposed to, I've got here, for instance, the Samsung Exhibit 2 4G, the Rugby Smart, the Galaxy Note, and the S2 for T-Mobile are all clustered in Vellamo results, even though those are running a 1 gigahertz S2, 1.4 gigahertz S2, 1.5 gigahertz S3 is one of them. And it's still getting similar Vellamo results, which we're not seeing on BrowserMark. So we're having trouble understanding why on Vellamo the OEM and I guess the OEM skin seems to have vastly more weight on the final result than it does on other browser-based benchmarks like raw SunSpider or BrowserMark.
Yeah, I think the easy response is it's the level of effort that's put into each of these devices by the OEM, right? So you see that some OEMs are clearly going with hero devices targeted, for worldwide launch, and they're putting this through all of the ringers, right? And they are looking at those devices and those scores on a minute-by-minute basis, and they're driving all of their teams to continue to push forward on some of those scoring results. It doesn't happen with every device, no. I think that the clustering you might see within specific OEMs actually speaks more to the level of involvement from that OEM in actually tuning for a benchmark or tuning for general purpose performance versus any anomaly that you're going to see from the CPU. We can, on our own, in our own labs, take the same processor and put 3 different software loads and get vastly different Vellamo scores as well, right? So it's not just the CPU and it's not just the SoC. It's also the level of effort and the dedication to performance that I think you see from a lot of the OEMs and the software builds they put together.
Yeah, because right now we're seeing, for instance, just to give you another example in our chart at least, and maybe our Vellamo scores are wrong, but in our chart, the LG cluster is significantly higher than the Samsung cluster. So you have a situation where the LG Lucid is representing greater performance than the Samsung Galaxy Note, which I think you'll agree is not necessarily accurate across the board.
I think what you're saying is that the Vellamo score might not be indicative of a true user experience on the device. Yeah. Yes. So I think you'll see that as well. And I think what you'll also have is a lot of OEMs tuning for specific benchmarks, right? I mean, we've seen this. We've kind of looked at devices and compared their Vellamo scores versus something else and seen that.
HTC is clearly tuning for Vellamo.
You have no comment on that.
One more question. Can we talk about, I think some of that difference there is just primarily because what Vellamo is running in is WebView, and what BrowserMark runs in is the browser. You know, and obviously those are very different. So what my question was is when further down the road, when WebView sort of becomes this orphan platform, which it already is in 4.1, sort of, you know, like it's WebView versus Chrome. What becomes the mitigation for how you guys test in a realistic manner?
That's a good question. I mean, that's something
the other thing too is, do you guys have any plans to open source everything? I think a lot of the trepidation would go away if everybody could do their own code review. You know, when Vellamo first came out, like I took it apart, I took the APK, disassembled it. You can look and see everything is just HTML and JavaScript. I mean, obviously, it's another thing entirely to look at how you actually measure what's going on inside the WebView container. But I think that would go a long way to sort of eliminating that line, you know, because ultimately it is going to be always Vellamo by Qualcomm, right? Right. But if it's open source and everybody can do their own code review, then I think a lot of they're cheating here, and we can't really tell either way.
Right. No, I agree with you. I think the open sourcing doesn't accomplish much from a technical perspective. I think we get very little commentary on the code. I think what happens is everybody says, "Oh, well, it's open source, right? So it must be good."
Yes.
I can understand that a little bit. It's something we have evaluated and we can continue to evaluate. I mean, some of the tests are already open source, like the JavaScript test, right?
Yeah, obviously, yeah.
Clearly you can go and take a look at SunSpider or via benchmark. On your first question of the migration of WebView to ChromeView, I think that for at least the next 6-9 months, or at least the Jelly Bean release cycle, you're going to see a number of OEMs continue to use an Android browser, right, or kind of a native, a standard browser instead of kind of quickly migrating over to Chrome. There's a lot of investment they've made into those browsers over time, right? And so, there's a lot of UI enhancements, a lot of things they've been doing around those. And so I think it's, they're going to take a look at Chrome in the same way they take a look at any other third-party browser. Of course, being part of GMS now, something different.
Yes.
But I think we're going to have to morph as well, right? We're going to have to migrate the thought process to being one of ChromeView or WebView or some mix of the two in which we can accurately test and continue to drive mobile browsing benchmarking on devices in which Chrome is being used as the primary web browser. Right.
Great. Thank you very much, Mike. And again, all of these speakers will be available after the presentations are over for one-on-one in-depth conversations. And speaking of BrowserMark, we actually have a representative from Lightware here, Timu Attila, who will actually present and provide you an overview of some of the stuff that they're doing. And we're very excited about it because, again, the focus has been on user experience, and I think they're one of the leading